This constitutes all available data. That information is not available.
Then you will remain silent until further instructed.
Confirmed.
If you didn't want the answer, you shouldn't have asked the question.
Brack, what are your limits?
They have not yet been defined. My knowledge is virtually infinite. My secondary ability is to logically process that knowledge and make accurate predictions. Instructions are not needed if commands are succinct. That is better. Our relationship will be best served if your statements are free of ambiguity.
You know what they say. No good deed goes unpunished.
My interpretation of the data leaves little room for error.
I am checking. Kindly wait. I have the information you require.
Of course, I'm properly switched on. Having depressed the activator button, what else would you expect? Is that a question?
Yes.
The question is futile.
All principal circuits are operating at full capacity and cannot receive new programs at this time.
This constitutes all available data.
Howdy do. Howdy doody. Very bright in this room today. Anyway, I wish I could say the same for the mirrors. Let's just check we've got some audio. Howdy do. We have some audio. We have a bit of audio. A audio, yeah, what's that cross between audio and a hoarding? We got a bit of that as well, got a bit of both. Anyway, so what are we doing today? Weakest link. I've come to realising that a lot of people, maybe, not sure, but as far as I was concerned with my K40, going back when I was using it, I gave the mirrors no, thought at all. Never touched them. Never even thought about cleaning them. Never did anything with them. Nor the lens. And then I wondered why it wouldn't cut, or not cut enough. The fact that it worked at all, which for me was amazing. Anyway, but I think we're losing a lot of power through the mirrors. A hell of a lot of power is being lost through those mirrors, maybe. Unless what I'm seeing is some kind of surface that I've cleaned off with my isopropyl alcohol. Anyway, the mirrors that come with the K40, I'm not so sure. Maybe they've gone funny with age, a bit like a CD-ROM. Maybe the backing has somehow been affected by bacteria, don't know, aging, don't know, but I'm pretty sure the mirrors are rubbish, basically rubbish. Now, I haven't looked into it in great depth. No pun intended. I haven't looked into it in great depth. Not surprised with all the muck that was on them. Anyway, I'm not complaining, I'm just saying that's all. Anyway, let's catch up. I haven't been on for a few nights, I think. And that's because I've been busy, very busy, making more. Anyway, so we've got on our screen at the minute, we've got the mirror 1, mirror 2, mirror 3 and lens. So, from what I can gather, it matters not how far your tube is from mirror 1. A mirror's a mirror. Now it only matters. Imagine if this mirror is dirty, and this one's dirty, and this one's dirty. You've got a nice clean signal going in here, but out of the other side, don't know where the power's going to. You can't possibly be getting a 100% reflection. I doubt you'll get a 100% reflection even on brand new mirrors. There's got to be some kind of loss anyway. But imagine if you've got dirty ones, you're definitely not going to get 100%. So that's one mirror. Then you bounce off another dirty one. Pitied, whatever, deteriorated. So whatever, you start at say if you start at 100%, you get into this mirror, you bounce off it, and then let's say you're on 70%. Then you get to another dirty mirror, you bounce off that. Let's say you're lucky if you've got 50%. And lo and behold, you've got another mirror that's dirty. So you could be down to, say, 35%. And you haven't finished there, because you've got to go through the lens yet. Now if the lens is dirty, you could be down to 10 or 15% on the power. So anyway, I'd want to do a bit of an experiment. We might have to ask ChatGPT-4 for its 2p worth of input. Now I'm still not 100% sure if I've inadvertently cleaned some kind of reflective film off. I don't know, but I think it's just the smoke residue off cutting wood. But what I have got, I'll tell you what I've got, I can't get to it in a minute, it's in storage, as in there's a lot of stuff on top of it. A brand new K40, a grey one, which has never had any usage other than me testing it. Anyway, so I've got to do some more tests. Yes, you can buy new mirrors. I'd rather use the K40 holders and stuff if I can and get the mirrors to fit it. But I've cleaned them up as best I can, and they're pitted, and some of them I can't see a reflection at all in them. So I don't know what. Imagine this. Imagine the mirror is got residue on it from the smoke. The laser is hitting the mirror, or the residue. It's generating a hot spot. Instead of reflecting cleanly off to the next mirror, it generates a hot spot. That hot spot is then what's on the other side of the mirror. It's some kind of metallic, don't know, is it mercury, something like that, something silver surface is on it. But you get a hot spot. What's going to happen to that? It's going to delaminate, it's going to discolour, pit. Something's going to happen to it. And I'm looking at the mirrors, unless I look at a brand new set and compare against the used set. So anyway, what I'm trying to say, you can probably wreck your mirrors by using them when they're not clean, because the surface, if it's not reflecting it off, it's got to be going somewhere. So it's, the only way it can go is as heat. It's got to be dissipated as heat. That heat's going to either warp your mirror, take the surface off the back, pity it, something like that. Anyway, so I think that's why I'm getting hardly any reflection off the one mirror. Now mirror one, the one closest to the tube, that is the worst one. So that obviously it's right next to the laser, it takes all the brunt of everything, and it's not easy to clean because it's so close to the end of the laser. It's not easy to clean, you'd have to take it apart. Anyway, so right, so there's that. What else do I want to accomplish today? I want to check the mirrors and find out a bit more about them. I want to show you what we've done so far on the original, if I can, with the drag chain and stuff, and the bits of mirrors and brackets they're made. Then I want to Well, I've got some handles to model. I've got to redo these. Let's just give you a full screen view. I've got to redo these plastics, so I've got to make the tube clamps, and I've got to redo the pockets, make it bigger. This is the right size to fit round it. It's just need the holes. I was designed it around 5, but for some reason the pockets are too small. Don't quite know why. Maybe my milling bit is worn out. It's not giving the required width anymore. Quite possibly because I've used it for milling aluminium, which without cooling. So anyway, we got that to sort out. What else have we got to sort out? Yeah. Oh yeah, I've got to cut a piece of aluminium. What else have we got? There's all sorts of stuff. Anyway, let's do something. So we've got now a set of brackets that, let's call them first offs, first and last offs, because as in they required a lot of labour, and now they're of no use to me really. They've changed the design, so made a few mistakes, changed the design. So I ended up with some, don't know what we can use them for, packers, skids, put them on the corners of the machine maybe, don't know. Anyway, so there's that wasted, and we've got lots of plastic that's wasted. So anyway, how can I get you to have a look at this? It's difficult to do, but I've cleaned it all off. I've got the drag chain. I'll have to bring it down when I... Tell you what, we'll have a look at that later. When the sun goes down a bit maybe. A bit brighter here, you can't see a lot. Anyway, so let's get on with something. Let's go over to the model. Okay. Yeah, so this mirror is all pitted and hardly any reflection. This one's better. This one's not so good. Not so good pitted as well, and the lens, can't tell, looks okay. Anyway, so there's all that. So I need to... Oh, my elbow's hurting. Why is that? Anyway, so what do we do first? Tell you what, let's model a bracket. That's easy. That'll get us into the flow again. I've got to model these brackets, these door brackets I found. So I suppose we could model them. Yeah, let's model them. It's got to be done. What does the thumbnail say? Let me just check the thumbnail. Have I even got the thumbnail on? Yeah. The weakest link, the mirrors. Yeah, we know the mirrors are the weakest link. I tell you what, before we do the... Let's do some research. Let's do some research. I'll just bring up a ChatGPT. Friendly neighbourhood ChatGPT. Right, here we go. Right. Laser Chinese K40. Have I spelt Chinese wrong? What's the matter with Chinese? Okay. K40, and we want to say to it mirror 1, 2 and 3. Do they have any special properties? See what it's got to say about that. Of course it's gonna... Yes, mirrors 1, 2, 3 in a Chinese K40 dyslexic, sorry, CO2 laser machine have specific properties and requirements. Here's a breakdown of each and their special characteristics. Right, here we go, we're learning something now. Overview of the K40 laser mirrors. The K40 laser uses 3 mirrors to guide the CO2's laser beam. The CO2's laser beam. The CO2's? Okay. From the laser tube to the laser head, which contains the focusing lens. These mirrors are typically mirror 1 mounted at the laser tube's output, mirror 2 positioned on the opposite side of the gantry, mirror 3 inside the laser head directing the beam down to the lens. Yeah. Special properties of the mirror. Material. Most standard mirrors in K40 lasers are denim, Mo. Very durable, oxidation resistance, and ideal for dirty or poorly ventilated environments. Slightly lower reflectivity. Silicon Si, coated with gold or dielectric materials. Higher reflectivity, 99.5%, but more fragile. Copper Cu, excellent reflectivity but oxidizes quickly. Reflectivity. CO2 lasers emit at 10.6 micrometer infrared. Mirrors must be specially coated or polished to reflect at that wavelength. Well, I've probably cleaned mine off then. Normal glass mirrors do not work. So, yeah, problem. Typically reflecting reflectivity 98%. Size. Standard K40 mirrors are 20mm diameter and about 3mm thick, but check your specific machine can be very thermal and environmental tolerance. Must tolerate moderate heat and not degrade with laser exposure. Denim mirrors are preferred in industrial or dirty environments due to their resilience. Do mirrors 1 and 2 and 3 differ? No, in most K40 sets all 3 mirrors are interchangeable and share the same specs. However, the alignment mechanism and mounting can differ slightly between them. Tips for optimal use. Keep them clean. Even small specks reduce power. Replace if you see burn marks, pitting or drop in power. Consider upgrading to higher quality mirrors, gold coated silica for better performance and efficiency. Would you like? Right, I cleaned mine with isopropyl alcohol. Cleaning is a common method, but with some important caveats to ensure you don't damage them. When is it safe to use isopropyl? If your mirrors are metallic like molybdenum or polished copper, IPA is safe. Okay. Dielectric coated like gold coated silica, IPA is generally safe, but you must be gentle to avoid damaging the coating. Things to watch out for. Don't rub too hard. Wiping aggressively can scratch the surface or strip coatings. Use a lint-free cloth or optical tissue. Paper towels or cotton swabs can leave fibres or scratches. Avoid soaking. A light dab of IPA on the cleaning material is enough. Don't flood the mirror. Inspect for damage after. Look for cloudiness, pitting and rainbow-like marks, which could indicate damage or residue. Best practice for cleaning mirrors. Blow off dust and with compressed air. Dampen a lint-free lens tissue or soft microfiber cloth with IPA. Gently dab or lightly wipe the mirror. No circular scrubbing. Let it air dry or gently dry with another clean dry tissue. If performance drops after cleaning, check if mirror alignment shifted during cleaning. Consider replacing if there's any visible coating damage or significant power loss. Right, okay. My mirrors looked orange in colour before I cleaned them. Now they are dull. Now they are dull grey. There is pitting and blemishes. Pitting and blemishes. Mirror one, not good reflection. Thanks, that's very telling. Based on your K40 mirrors were lightly gold coated silicon. The orange tint is a giveaway. Here's what likely happened. Coating. The orange colour was the gold coating, which gives 99% reflectivity. After cleaning, they turn dull grey and show pitting and blemishes. This means the gold coating was stripped or damaged. Mirror 1's poor reflection confirms the loss of performance. What probably went wrong? Too much pressure or abrasive material used when cleaning, even slightly. Contaminants or previous burns on the mirror made the surface fragile. Some gold coatings are very thin and delicate. They'll easily damage without ultra gentle cleaning methods. What to do now? You'll need to replace at least mirror 1, but ideally all 3 mirrors so they match in quality and performance. For most K40 users, molybdenum is a good upgrade. It's very hard to damage and needs less cleaning, though it's slightly less reflective. Upgrade mirror mounts optional. Some games are poor mirror mounts that make alignment harder and expose mirrors to more contamination. Consider better sealed mounts or spring-loaded design if you're upgrading. Until you replace them, you'll have to reduce the laser power. You'll have reduced laser power. Alignment might be harder due to uneven reflection. You risk burning more material into the damaged mirrors, making future cleaning worse. Would you like to find a good mirror set online or help? Yes. Oh dear. Just got some lemon. It's a bit strong. I didn't dilute it. I'm sorry to hear about damage. Based on your script, it seems that gold coating on the mirrors has been compromised, leading to a reduced reflecting performance. To restore optimal function, replacing the damaged mirrors is essential. Oh dear. Right. Recommended mirror replace. Durability, blah blah blah, gold coated silicon. 20, there's a set. Cloud Ray. No prices available. To assist with the installation of new mirrors, consider the following: mirror nut removal tool, lens cleaning kit, ensures your mirrors and lenses remain free of debris. Mirror alignment. Poor alignment is crucial for optimal laser performance. Use a brief guide. Install the new mirrors securely. Mount the new mirrors in their respective positions. Use a laser pointer. Place a laser pointer in the laser head and aim it at the first mirror. In the laser head and aim it at the first mirror. Place a laser pointer in the laser head and aim it at the first mirror. Adjust the mirror until the beam reflects into the second mirror. Adjust subsequent mirrors. Fine tune the alignment to ensure the beam is centered. Right, I want to use a red laser pointer to set up the alignment. So swap. So my tube, my CO2 tube is set back from mirror 1. I want to place the red pointer in front of the tube. Sort of swap it out. Mirrors. Smart and effective approach using a red line to replace it. It's a safe and precise line and dangerous to work with raw power. Here's how you do it. When you set back, you want to place a red laser point in front of the tube roughly at the beam's origin to simulate the beam path. That will work very well if done carefully. How to do step by step. Mount the red laser at tube height. Key is to match the height and position to see the beam exactly where you would exit the tube. Use something like 3D printer or machine adapter. Yeah, blue tack. Ensure laser is straight. Place a mirror or target directly in front of the pointer. Make sure the beam is not angled up, down, sideways. Should be perfectly parallel to your gantry rail. You can use a long straight edge or ruler to help. Blah, blah, blah. Run alignment with the red beam. Now align your mirrors as normally would. Align so that the beam reflects directly to the centre of mirror 2. Mirror 3, straight down through, yeah. Ooh, verify the tape. Verify with tape. Use marking tape. Things to watch for: red laser beams might not travel exactly the same path. Beam due to beam divergence or offset angle. This method gives you 99%. After aligning the rate, do fine tuning as the real. Yeah, optimal. So if you want to get fancy red laser mirror alignment tools on Amazon, pre-align the magnetic bases or tube adapters. What? Right, okay. Can you make your own mirrors? Yes, you can make your own mirrors, but with important limited caveats. Homemade mirrors are possible for experiment, but it rarely matches the performance, precision and safety of a commercial grade mirrors. Designed for 10.6 micrometer infrared lasers. Here's a detailed breakdown. You can make your own mirrors. Technically possible, but not ideal. You can create a makeshift mirror using materials like polished copper, Polished molybdenum, difficult. Gold polished, gold plated substrates, possible. No. Polished copper. Can work well if polished and cleaned frequently, but oxidizes quickly. DIY polished copper mirror, the best way. Okay. Alright. So we need to find some new mirrors by the looks of it. I've got a brand new set. I don't really want to mess with the mirrors on good working setup. So I don't know whether the damage on mine was done before and all I did was wipe off the residue, or did I wipe the surface away? I've got to think that I wiped the surface away, but before I touched them, they were all matte and blemishes and this colour, you know. In fact, that colour isn't the colour anymore. It shouldn't be that colour anymore, although it might be. Let's just change that. Alright, let's change the colour. So that's going to be some kind of metallic. No, it's not that colour. Okay, so it's metal. Is that it? Probably. And then we've got the other side of it. Can't grab it. Now I can. Right. So we've got that side, and it needs to be a clear mirror. In the model. Is that okay? Probably. We need to paint that one as well. Yeah, that's it. It's supposed to be a different colour maybe. Right, so why is that colour? Yeah, it's not supposed to be that colour. No, it's supposed to be silver. Okay, so it is. Oh la la. Another one here, look at that. Okay. Alright. Okay. Anyway, I've lost track of where I got to. So, yesterday I milled out, cut these, milled them out, and attached the switch, attached the mirrors. Now this mirror is a bit, let's say, not flimsy, but it does move. And it's fastened underneath here. It's a little bit far. See how it's fastened to this right on the end, so it gives it a bit of this way. Not a lot. I don't know what will happen if it trundles along. And also the drag chain, when the links move, it sort of vibrates down. So each time a link changes position, there's like a joop, 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 joop. So together with this oscillation and the chuk 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 might be enough to make the mirror move. Now we can probably do something about it, like fasten this bracket to this stud to give it some stability. I'm inside the model. Anyway, so right, so what I've got to do later on, yeah, I'm still trying to work out this. Is that right? Yeah, so that's what I've done there. And I've got to make this fit there. So I've got to go and carve that out. And then I've milled this out to 5mm. And it needs a nut on it, or to be a 6mm fixing, because this is so close to the top frame top. As you can see, it's so close that the nut, I've had to use a different, no, I haven't been able to put that in, because in reality that is too close. So that's too close to that. So I don't know why it isn't, and I've lost control of it. Yeah, I don't know why it's, so that's just too close there. That fixing, even though it looks, when I put it in, it's sticking up because it's touching there. So I've got a bit of space underneath, so it needs to be, probably needs to be smaller, this one. And I've put it in and it's flush with that, so it might need another set of holes here and then lower in a bit just to get that, or mill a new hole out, or elongate that hole and move it down. Don't like the idea of that, but I'm low of angle now. I've got no angle left, not that size. Anyway, so I've got to work out how to do it. So I've got, I should have put really, there's no room for a nut, if you know what I mean. There is no room for a nut, because the plastic will sit there and slide across the door, so it can't go any higher than that. Even that's too high there, it needs to be flush. But I could make another one and lower it. So basically I could use the same bracket, take it off, and maybe lower it. Anyway, I've got all this to do. I've got to put the pulley wheels on and the belt. I've got the new things fitted. I've got these new plastics fitted, so I can put the belt in now if I wanted to, and run it round there. And I've got this yeah, pushing against there, that's working. All that seemed to work. Anyway, I'll do a bit more off screen and we'll come back to it. We'll come back to it, so I'll do a bit more off screen. I don't know whether I can show you this bright light. Probably not. So anyway, I'll have to come back to it. Alright then, anyway, that's going to be it for now. I've got some stuff to do, but I'm very tired today. I don't know why, it must be the sun. I think I've got a heat stroke. So anyway, leave it at that, and I'll do a little bit more off screen, and I'll catch you on the next one. Thanks for watching, have a good day, and bye for now.
This constitutes all available data. That information is not available.
If you didn't want the answer, you shouldn't have asked the question.